So we just saw that stacks are relatively simple data structures. So covering stacks is fairly straightforward. We're going to build a basic stack using references just like we did for a linked list. And then we're going to move on and cover, and then show you how to use stacks in various applications. So a stack of stuff is defined fairly straightforward. It has a public, we're going to go ahead and make a node class, private static class node e next and e item. I'll use item this time around. So node next e item public node, and this will take in item e item this dot item is equal to item. There we go. There's your constructor. That's our node. We don't really need too much for it. And now for our stack, we will use a private node e top. That's really all we need. We don't even need to keep track of the size. There are 4 methods we will use. We will use so public e pop to pop an item off the top of the stack. Public e push to push an item on top. Push to push an item on top of the stack. Void. It's e is typically you can return the item that you're adding. I don't know why we do that, but we can. I'm just going to leave it void. Public e peek, which takes a look at the top of the stack and returns what's there without removing it. And then finally, public void or public boolean is empty, which we'll do first. So is empty is simply, we can tell if the stack is empty based on whether or not the top is null. If the top is null, then the stack is empty. So we will say if top equals null, return true, and then I'll condense this down after we're done. Else return false. But since if this statement evaluates to true, will return true, and this statement evaluates to false, will return false, we can just condense it to one line, which is return top equal to null. If this is true, then is empty will be true, and if it's false, is empty will be false. Peek should be fairly straightforward to do, which is that return top dot item. So now for pop, that's fairly straightforward. We need to, pop. So for push, we need to put an item on top of the stack. Otherwise, we're getting nowhere. So node e adding is equal to new node item adding dot next is equal to top. So just like with adding a new head to a linked list, what we're going to do is that if we want to add an item, add a node to a linked list, we create that item. Sorry, we create a node for that item. We then connect that node to the stack that already exists, and the only thing we have access to is the top of the stack. And then we just make that new node the top of the stack. That's it. That's all we have to do. Literally it's like add to a linked list, except the only condition only with one condition. We don't have to check for indices. Can't possibly add anywhere else. The only way you can interact with the stack is through the top and the bottom of the stack. Or sorry, through the top of the stack. There's nothing else. Can't interact with the bottom. So, one more method. All right. How do we do? Right. So, this one's fairly straightforward. This is removing the head. So, to return is equal to top dot item. So get the item out of the top, and we will return it. And then we need to go top is equal to top dot next. Just advance top to the next item. So get the item out top, advance top to the next item. That will remove the original item, just like removing the head from a linked list. So all these operations, by the way, are constant time operations. And that's it for the stack. The stack is an extremely simple data structure. That being said, it is an extremely powerful data structure. Its limitations make you think more about how to use them, and as a result, you actually will use them to do very interesting algorithms.